Jed, you got first. YouTube is online. All right. Let's go. No more Mr. Nice Guy for... Yeah, dude, I wouldn't show mercy either. Can I claim my own first, actually? I think I can. Oh, yeah. Oh, my. It was this triple integral. Take the free points, too. Wait. Oh, no. X squared plus y squared is less than 16. I told this person wrong? No. Wait, what? You divide by 2, not multiply by 2. Well, what's wrong with this work here? They meet at z equals 4. I mean, I'm not gonna have anything to post in this shit, but if you want to see it for yourself, if you plug z equals 4 into this, how is this radius 4? Because it's rooted. You're supposed to... You divide by 2 and then you square it to get rid of the square root. They got rid of the square root, but they didn't square the other side. Wow, I made the same mistake as this person. I get it now. I did. Okay. All right, well, I'm glad other people corrected me there. I should go back and upload them. Be a good citizen. Okay. Hey, Viv. Chris has 3 pencils. Pam has 4 times as many pencils as Chris. How many pencils does Pam have? Is there a trick here? Chris has 3 pencils. Pam has 4 times as many pencils as Chris. Well, it seems like the obvious answer is 12, but is there some trick with the wording here? Chris isn't a pencil, so therefore Pam has 0 pencils. I don't know. It's the only possible trick that I can think of. Maybe Chris is a pencil. We're not given that information. So you give, okay, 12. That's my answer. Correct? Oh, okay. Classic overthinking, I guess. I don't know why I'm looking at this, but it might be interesting. It's apparently a Python question. Intro to Python. The realtor? The realtor. Their relationship was irrational. All right, Aller, I see you. What? For each item not the same? A reflex angle today? What the heck? I've noticed what this is asking. And moving on. The wording is all sorts of weird to me. I think that, well, there's like if you want to dig into it more. I think that chart there, like the actual table was their flow chart. It seems, because they say add to the flow chart above in the bullet point. I really don't know. I have no clue what's going on with the question though. Well, they're doing math in pen. It's a Chad move. Yeah, I know it's a Python question. I just wanted to look at it anyway. You're trying to find the logic of a function? Okay. That has to be a t. Is the 2/3 of a second exponent. What is the value of the constant here? Well, this is a little bit of an open question here. I don't think it's that, Chad. That looks like a t to me. This looks like the result of an integral. Initial problem was to integrate, what would the exponent have to be? T to the 1/3? T to the 2/3 plus C. Being given more information, like a point that the function should pass through. No, 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 no. There should be a negative sign if this was the problem. Dude, this is not enough information. There needs to be a negative sign, because if you drive this back, it's t to the negative 2/3. Just use Wolfram, let's not play guessing games. D by dx, 3/2x to the 2/3. Just make completely sure that I'm not making some basic algebra. Wait. Did I see? I reversed my power rules and exponent rules, evidently. For integrals and derivatives. Okay, what? We just need more information from that person. Year 12. Oh yeah, no, I looked at them, but okay. It's the same person. Come on. No, that's an answer. As an answer. Hmm. Reddit is pretty answered so far, it seems. Let's go to learn math. Parameterizing functions. Let's see. Cylinder surfaces that intersect, you want to do something with them. Find the arc length of the intersection or something, so you need to parameterize them. Can solve our variable and change them to t. Right. Okay, so I think I can give them a bit of an answer here. I don't know if I have the most complete answer, but we're not necessarily replacing x with t. We kind of are, but I feel like we need to make a bit of an extra point here. So if they have x squared equals 2y as they did, they solve this for y by dividing each side by 2. They turn it only into the equation y equals t squared over 2, but you should have two simultaneous equations, which is x equals t and y equals t squared over 2. And that's why this whole thing works. Yeah, sure, Spetri. No worries. One equation into many. When you have y equals x squared over 2, you're taking x equals t and y equals t squared over 2 simultaneously. It isn't just y equals t squared over 2. Both of the equations are true at the same time. X equals t is this is a simple technique to parameterize a function. Certain curves, such as a circle, require different parameterizations. Parameterizations. You can technically always parameterize whenever you want. It's just more or less helpful in certain situations. We use parameterization to simplify calculations. If you have a curve x squared, how should I phrase this? Can be easier if things are parameterized. It's easier, or it can be easier, to say find the intersection of two curves, since you can equate the x's with the x's and the y's with the y's, rather than having them mixed together. Okay, I hope that's getting at what they were asking about. Spetri, I see you are sending it to me. Let me bring this up. Zach, thank you very much. The only Lynn for you. Thanks for the follow. Hope your question and answer went well. Welcome in, everyone. the real analysis discussion we were having this morning, I thought was another really nice conversation that I liked. It did lots of analysis questions. Oh, nice. Yeah, I saw you're working on the cosecant of n as a sequence question because Anders mentioned it to me yesterday. I kind of want to go back and watch that VOD if and when you do post it because I'm kind of curious to like hear about it too. Because I was able to like maybe talk a little bit about it, but I wasn't really sure what to say. Check if the distribution matches. Okay, so this is from Spectry. We have to check if this distribution matches a normal distribution. It is unbounded. You're convinced in the sketch. Yeah, exactly. I would think that it has to be unbounded because you never know, like, when cosecant blows up, where exactly on that, like if you're on like the little bottom of the bowl or if you're at the top of the bowl, I guess. If you see my visual metaphors, that probably more confusing than anything else. So Spectry, it looks like we need to make a histogram. My guess here is that we need to make a histogram and we kind of make a judgment call on whether it's approximately normal. Like if or by eventually you're called like a bar chart. Be a given error probability? I don't think I've heard of that. Well, what are these, the second and third columns here? Looks like these are ranges where if we were to make a histogram, these are like our buckets. Oh, maybe it's a frequency chart. No? Oh, these are the midpoints of each interval. I see. And this is the frequency? Okay, yes. Okay, this is a frequency chart, and the middle column are the midpoints, as you said. Okay, thank you for that, Spectry. Frequency table. Do they want bucket sizes or midpoints? I wish they gave an example. Enter your scores. Oh, this is, oh man, they want the raw data there. No, let me... They all want the raw data. I want to give them... Learn the method, but all your materials in German. Really? Hmm. Let me see. Maybe I can find some kind of explanation in English, because I would literally draw a picture here and kind of approximate. And like the way we did in my class, just literally just like make a judgment call. I'm betting it's going to be a little. It would be hard to call it. You might be able to call it normal, but it seems like it's going to be a little skewed. Just like it has a peak here, and that kind of gradually tapers off compared to the upper side. Fitting and distribution tests. Yeah, this is the exact technique that how I was taught. This is not very mathy. I'm trying to think of a way that you can maybe, let's give the whole image to Google Translate and see if we get any hints. Weight of a group of 2100 people is determined. The following numbers are determined. Test the hypothesis. Distribution conforms to a normal distribution. Interesting phrasing. Test the hypothesis. Yeah, sure, Spetri. Maybe. I might recognize something. Anders, 10 streams. Thank you. I appreciate that. Oh god. The number of sides in an undecagon times the number of sides in a nonagon. A nonagon is 9. Undecagon. It's something times 10, thinking about the roots of the word. Undeca. Is it 90? Oh, that probably makes more sense. So 99. Undecagon. Oh, or the much more familiar hendecagon. 11. Just to be sure I'm right about the nonagon. Yeah, 9. Okay, 99. Taking those points and running. Sorry, those coffee beans. It's a bit messy. How dare you, Spetri? I expect only the cleanest of work if you can't tell from the... Nonagon, isn't it? It's fun to write these. I bet you're having fun. Really? Okay, so this is like a helpful thing to see too. Zach, I'm super excited for like that possibility. Obviously you probably have your hands full with like other stuff too, but I'd have to be like all in for it. I don't know, it sounds like it has no sides. It's a circle! Oh, man. Is that phi? I don't remember. What? I'm trying to think if there's a distribution that I learned that matches that. This looks like a good old-fashioned Z table. Oh, maybe not. Or maybe this is I think it's a lowercase version of the same Greek letter, phi. I might want to put this into Google Translate and see if it gives me a clue. Well, this looks like a normal distribution. They just use a Greek letter that I'm not used to. Or these values look like Z values. Yeah, it looks an awful lot like a Z table. They are, Zach? Okay. How do you use it to test if your table here is normally distributed, though? Huh. German type looks like standard norma? Normal? Oh, yeah. That's a good point, too. what's happening in these? Are you getting expected values here? I'm assuming that in Germany you guys use phi for the normal distribution, but we always use z. I guess, or like it's referring to like this z here. I think. I mean, I think a z table is like a more casual way to refer to it. It should be called like the normal distribution table or whatever. But the value as u calculator. Oh, okay. So this is actually going to end up being chi-square to test if it's approximately normal? So I don't know why you would use the normal distribution itself. Like you use the normal distribution to calculate expected values. But then to test and get to basically generate your table of expected values, but then wouldn't you need chi-square? I don't know. I haven't done a problem like this before. So there's between, like, in American schools, you just eyeball it. That's really all it takes. Let me put my mug away. I'm a lot of tea. By the way, this problem looks like it takes a lot of work. No, it's all good, Spectre. This wouldn't be easy to figure out how you say it in English. Okay, so it looks like you got the mean of the data here, and then you get the standard deviation by hand, which is really annoying to have to do. Oh my god. That sucks you have to do it by hand. But alright, standard deviation, mean, or wait, squared is variance, and then square root it for the standard deviation. Wait, you get 666? It's because statistics is the devil. Okay. And then you're getting your expected values here. So you're taking f of 60 minus f of 55. What's special about these values? Oh, probably because we're writing them in the chart. Oh. Wait, yeah, 60 to 55. So that's that first. Okay, yeah, so that's the expected the value for the first row there. Oh, 03. So you're getting it as a percent, and then we are going to have to multiply this percent by the sample size, I would think. Is there a more direct way to do that? Yeah, because this is the standard normal distribution is centered around 0 and standard deviation 1. This certainly wouldn't be like that. No, I guess it makes sense that you have to get the probabilities here. When you get this 0.035, I don't know what the last one is, but that number, that's just a proportion, and you're gonna have to multiply the sample size by it. Like, do you do that somewhere? to get the actual expected number of people in that first row? I guess you do, because that looks like a different number there. Can I find where that happens? Or do you just like doing the calculator and input it directly, maybe? Okay, okay. So good. Okay, I understand where this chart comes from then, or this column. This next column, zoom and enhance. This is probably some kind of error measurement. I've hard time reading what the letters are, like the deviation from the expected. Oh, delta n squared over delta n squared over the expected value. Really? What is, or delta n sub I? What is the delta n sub I? So that, yeah, that's what I'm thinking. But I don't remember having to calculate something like this for... Oh, wait. That might be this. Oh, okay, okay. Yeah, okay. The delta n is the O minus E, as I'm familiar with it. Okay, that's good call zone. And then, yeah, you sum these up. Okay. This makes sense. I never thought of doing it like this, to be honest. It's all good. It's Patrick. This method makes sense to me, though. So for your chi-square, you get 36.73. Do we have 6 rows? Do we have more? 1, 2, 3, 4, 5, 6, 7, but you do subtract 1 for your rows, for your degrees of freedom. It is a way to check for normality, though there are better ways. Really? You see, value was so far away from C, which is odd. So I would call this like chi-square, what you get here. I don't know if that's a convention difference or maybe a misunderstanding, but... I would think we go to 6, and then for chi-square is 36, we're probably going to be off the chart. Okay, yeah. So it's going to be a very small p-value. It makes sense to me that this isn't normally distributed. And I think like I guess I'm not sure exactly sure what C is. Maybe C is like your cutoff for when you would accept or reject. Or not accept, but, you know, reject or fail to reject. I don't think getting something this high is that unexpected, because if I were to do the eyeballing the data thing, it doesn't seem like I wouldn't expect this to be normally distributed just from looking at the given chart here. The bucket sizes, no, they're all the same. It's like a little bit skewed. If you were to make like a histogram of this. Okay. And in this case, we're really far away, which can be weird, but I think in this case it makes sense. So I feel like I haven't checked your work like that critically, but I kind of agree with your methods here, I think. The other part is I don't know. Oh, that's the C. They actually like give it to you. So yeah, 11.07 versus, wait, F equals 5. Is that degrees of freedom? Why do it should be 6, I feel like. So you have 6 rows. That C is different? Oh, okay, okay. So yeah, I mean, I can't tell you if you should have used a different way, I think, because I just was never taught this in the first place, or like what the different ways are, but I think this makes sense to me, the way that you've done it. So yeah, so sorry I can't give you like a more firm answer, but I think it's the best that I got for you. Yeah, no worries. Okay, so this person's asking about parameterization. It looks like they already got back to me, so let's see. Oh, I might have misphrased it if they're interpreting it. It doesn't represent an intersection. I think that's the potential application of like parameterizing. It looks almost too simple. For many functions. Two curves is a potential application of parameterization. but just parameterizing it, or parameterizing a curve can, or a function can mean anything. Doesn't anything to do with the intersection on its own. It doesn't have to have anything. Wait, if I have two surface terms of x, y, z, and I parameterize them, I get a vector. The vector of each surface, the vector of each surface doesn't represent the intersection. What represents the intersection is equating each piece of the vector. I hope that makes sense. You have two surfaces and parameterize them. You get two vectors to do with as you please, which may or may not involve equating their components. I was avoiding it in case you haven't learned it yet. I want to mention line integrals because that will come to mind for me for when parameterizing is helpful, right? Let's make sure that I'm actually not completely talking about my ass though. It's a line integral. It is possible to do without parameterization because that's what Green's theorem is, right? So I shouldn't say that it's necessary, but it's parameterization could be very difficult to express in a conventional, should I say conventional? I'll say with a normal integral. Although in other cases it is possible and easier. That's making in some cases it is possible, and it is actually easier. I feel like this explanation is a little bit messy. Okay, hopefully this doesn't confuse them more. I think I was on Learn Math. What's happening here? Miles per gallon, tank capacity, distance, price per gallon. Oh. Miles per gallon over distance to get the number of tanks. Should it be flipped? Well, you need to get the tank capacity. No. It wouldn't be flipped, but they need to multiply by the tank capacity. Oh my god, I'm sorry that I'm yawning so much. So the cost for the trip, I'm getting lost in trying to understand their work, but if I were to just, go take it from here, we want to work out how many tanks of gas we're going to need. So we want tank capacity, which is going to be in gallons per distance, gallons per mile, I guess. Well, no, tank capacity is just in gallons. That's where I was getting confused on too. Okay. So one tank capacity times miles per gallon is the distance that one full tank will get you. Then you want to do distance divided by that is how many tanks of gas that you need. And then you multiply by price per gallon. Well, then you have to multiply by tank capacity again, don't you? Why am I getting lost in their works so much? Just take some notes, I guess. Actually, do we need, well, to even get the total cost, do we even care about the tank capacity here? Maybe that's why I'm getting confused, because I multiply by tank capacity and then I'm dividing by it, so why do we need, to get the total cost of the trip, why do we need, like, tank capacity only matters for the number of stops. But, distance divided by miles per gallon will get you how many gallons of gas that you need. Then you multiply by price per gallon. Okay, that's the more direct way to do it, I guess. Okay. You do distance divided by miles per gallon to get to the gallons of gas needed for the trip, then multiply by price per gallon to get the cost of the trip. To put it all in one formula, cost equals distance times price per gallon divided by miles per gallon. Let's submit that, see what happens. Distance between two skew lines. Well, they should intersect, right? I was talking about the distance at any given, like. Oh, not in 3D. That's annoying. They're just giving you in two different formats to make you do extra work. Okay. That contains L1 and a second one that contains L2. I guess you have infinitely many choices, like. So you guarantee that the vectors share a point, you can choose whatever direction you want. It's been a little too long since I've done this, and I don't I don't really want to figure this out right now. Hmm. That's the equation for this variable. It's kind of an interesting question, but I'm not really sure. And I'm feeling. I suddenly started feeling super tired. I might just switch over to do analysis, which, I mean, that's not exactly easy, but at least I'm not giving advice to others if I do mess something up. And anyways, there's been a ton of questions out here on Reddit anyway. So yeah, let's do real analysis, because there's definitely some things that I want to look at, both from today and from Tuesday. Bring up both those problem sets. I'm going to start with today's problem set though. Just give me a second to get bring them both up. Okay. Good. So we made very good progress in class today. We got all the way up to 8A, and we talked a tiny bit about number 9, but I'm going to focus on 8B first, and then I think I'm going to look at 9. Everything else we pretty much did up above here. So were these functions discontinuous? The answer for part A was at every root of an integer. And these brackets are basically the ceiling function, or the next greatest integer function. Basically, if you have a decimal, just round up. Let's look at the ceiling of root x though. Let's collapse this down. Okay. Okay, so g of x is the ceiling of root x. People, let's plug some values in, because I know it's going to be a sideways parabola. Like normal root x without the ceiling is like that, but when you start taking the ceiling, it becomes a step function, and it's going to loosely follow that curve, but not exactly. So let's plot a few points here. 0. That's what I wanted to put in first, but not up there. X root x 0. Let's give it a decimal. 1. 1.5. 2. Maybe that'll be enough to give us an idea. So 0, 0. 0.5 gets square rooted to some decimal. I guess greater than 0.5, but still less than 1. So we're going to get 1 there. 1 square root of 1 is 1, so we get 1. 1.5 square rooted is still greater than 1. So it's going to get bumped up to 2. 2 square rooted goes to 1.4, which gets bumped up to 2. So actually we should go out a little bit further, because we can get perfect square now that I'm seeing it more. 3 is somewhere between, root 3 is somewhere between 1 and 2, so it gets bumped up to 2. 4 now becomes just 2. So that actually is still 2. So we need to go just past the perfect square. 5 is just slightly more than 2, and now we bump up to 3. Same with 6. Okay. So 1 after a perfect square is when we're going to bump up. So let's draw a graph of this, now that I think we've figured out our pattern. Let's go out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because 9 is a perfect square, so let's go 1 more than that. And for height, let's go up 1, 2, 3, 4. So we definitely have the point 0, 0. But then as soon as we get slightly past 0, 0, we get bumped up to 1. So let's do an open dot here, and we're going to go to the right until we hit 1 exactly. And 1 gets included here because 1 itself gives us an output of 1. Now once it goes slightly past 1, we're going to get bumped up to 2. And then that'll continue until we get up to 4. And now once it goes slightly past 4, we get bumped up to 3. And 3 is going to continue all the way up to and including 9. Then once it goes slightly past 9, you get bumped up again to 4. And then it gets cut off. Okay, so we are discontinuous at basically our x squareds. Well, at our we would say that we're discontinuous, I guess, at how did Zach, or like I said it verbally and then Zach like wrote it out for me. I think at n squared, where n this is really sloppy, or I feel like there might be a more succinct way to say this, but it's a positive integer or 0. I think there's maybe a more succinct way to express this idea, but natural numbers, what's our definition of natural numbers for the sake of the class? I don't think we're including 0. Cool, okay. I guess like that, I have the idea, so maybe the way that I'm noting it isn't the most important, but no, natural numbers do not include 0 in this class. Okay. So either way, I could do n union 0 too, but I guess it's the same as z plus, so let's not worry too much about it. Okay, so I think I get the idea for that question. What am I doing? Okay. So I want to look at 9 a bit. And I want to have these side by side, so honestly, I think let's pull a Dan and go to Paint, because it just seems like a convenient program to use to get 2 screenshots of these side by side. Just give me 1 minute to get these screenshots done. Copy, paste. Copy. Oh, sorry, screenshot. Now, no, don't save. Copy, paste. Okay. Now let me show my Paint. And bump that down a few. Okay, good. Okay, so another definition of a continuous function comes from topology. A function f that maps D onto R is continuous if, for any open set X that is a proper subset of R in the image, which is our outputs, then the pre-image inverse of X is a proper subset of D is open. I keep on adding in the then, but actually I guess the then really is there and it's just implied. Oh wait, Zach, there's a typo here. Definition, you need an I. That's not even the I is imaginary. There you go. No worries. It's pretty minor typo to be honest, but for any open set, maybe okay. So let's just take a relatively simple function. We're working with x squared, and maybe let's just try and attach an example. What? Oh my god, not that. Sorry, I want to expand out my paint a bit. Like that. And go up like that. Okay. So for any open set X, that's a proper subset of R in the image. So let's take what's the example image we were given? Okay, so specifically that has to be an open. Oh wait, the image of 0 to 3. Is the example that we were given here, in the image of that is 0 to 9. This is closed. So if I think we can equivalently say that the image of the open interval, not equivalently, but we can, if we wanted to, I think we can take the same numbers for our open intervals here. So I actually kind of already wrote the other component here. I just made them both open, but let's work for any open set. Well, for x squared, I just know that's continuous, so it should work. Should I look at a discontinuous function then? Because I definitely, like, you know, if in here, if our image is open, not a bad idea, okay. So yeah, but like with this, if our image is open, we definitely can't have a closed pre-image. Because if we were to include our endpoint of 3, we'd have to include 9 over here. So I think I should look at a discontinuous function now. I guess keep our lives simple and look at 1 over x. So if we want to look at -1 to 1, so we have discontinuity right in the middle here. I don't know if I should make it the 0 and endpoint or not, but let's just try this. Our pre-image, well, 0 isn't included in the image, so actually I can't do it like this. I have to make 0 an endpoint here. No, wait, this is image, not pre-image. These are my input. I was thinking in terms of the inputs. So if our image is, say, yeah, the pre-image is -1, 0, I guess, is what I was, where my mind was going. Which I guess maybe I was trying to do it in reverse with the image first, but we can just take our pre-image and work out what the image should be. For -1 to 0, we would expect -1 to infinity for our image. Minus infinity? Oh, I was thinking of... Thank you, Zach. I converted it into 1 over x squared in my head for some reason. Just so I need to actually see it, evidently. There we go. That's the function we're working with. For whatever reason, I was imagining 1 over x squared in my head. So that's actually... Okay. This function is continuous on R without 0. I mean, that makes sense. Like, each half of the function is continuous. I know that there's crazy, like, f of x is equal to 1 if it's rational and equal to 0 if it's irrational. That has whatever crazy properties that I don't remember now, but... Really try and keep things simple when I'm trying to figure out these definitions. Spoilers? I mean, I've already been spoiled on that. I did learn about it as an undergrad. I just don't remember anything about it, so I guess I've unspoilered myself by trying to, like, repress that. So what's happening here? So this is for, you know, our any open set in the image. If we were to take -infinity to -1, we couldn't name a closed set. Can we name? Wait. Right, we cannot name a closed set for this image, or we couldn't name a closed set for the pre-image that would match with this image. But, well, we couldn't do that over here either. So what's actually happening? Wait, so we should, if it's discontinuous, we should be able to name a closed set. Try that one? Okay. Oh wait, this is there's three parts to this. 0 for x equals 0. 1 for x greater than 0. So we have a point there, an open circle here, goes off like that, open circle here, goes off like that. Okay. What is f? What's the pre-image for -1, 1? But oh, okay, I was like, we're, like 0.5 isn't in the image, so that's where I was getting confused on this one. Like, we can't really name an interval for the image, as far as I can tell. Okay. Oh, you did that. Wow, spoiler, Zach. So what's the pre-image of 0? Wait, isn't it just 0? It still wouldn't be -1, 1. Zero is closed. Or we didn't answer this in class. Could it be both? I need to look at our definition. Oh, wait. It might be both. Oh, let me get these definitions on screen. It's only one this time? Oh, okay. All points in an interval slash set S have an epsilon. Well, oh, never mind. Yeah, it can't be open. It has to be closed, right? Because we can never name a second point that's in our epsilon neighborhood, because there's only one point in the first place. I was saying, oh, 0 is always contained in the epsilon neighborhood, but I don't think that's how you're supposed to think about it. Whereas 0 definitely seems like a limit point. Okay, you're dancing. I'll take that as a good sign. But, oh, wait, so is that all we need? Let me look back at the definition. The pre... Well, don't we need to talk about if it's a discontinuous, then for an open image, we should be able to find a closed pre-image. If I'm interpreting this right. But we have two closed sets here, don't we? So this, I don't see how this applies. For any open set, X is the proper subset of R in the image, the pre-image is open. All right, let's look at the better example. That's not a line at all, is it? Yeah, it is. I'm working on number 9 up here. It's an alternative topology definition for continuity. So I'm trying to work through how these two definitions are saying the same thing, but I'm still not sure exactly how. And Zach has given me an example to look at to try and understand it. You know, I'll just work up here too, just so we can have the question on screen. Get rid of that. So we have x if x is less than 1, or x minus 1. These are x's, I promise. Oh, okay. So what are we working with? I'll draw the graph up here. Just make that x equals 1. So we've got that when x is less than 1. And we've got this. Because when you plug in 1 exactly, you get 0. Okay. And so let's name an open pre-image. Wait, x greater than or equal to 2? Should I change the other one as well to 2? I'll just have a gap there? Okay. Yeah. That's going to go to 1 also? Okay. So what's the pre-image? Oh, not that. of 0, 2. It's the preimage of this here. Oh, that's okay. Because for here, we have to do open interval 0, comma, wait, yeah, union 2, comma, wait, yeah, 3. And those aren't open. Okay, they're not closed, but it's also not open. Okay. And so if we were to try and apply it, like I want to try to apply it to like this one now too. It's a little bit harder because like I wouldn't say that the image is -1, 1. I would say that the image, I guess maybe this isn't the, will this definition of continuity apply? Is the union? Right. So this would be still considered closed. So would that definition of continuity just not apply to a function like this? Like it doesn't say anything about it? Closed implies closed is, I think, another definition of continuity. Okay, because I was wondering about like the logical equivalence. Like if you have like P implies Q implies like if not Q then P. And I was trying to like figure out if it's like something like this, where if you can name a closed set, then find an open set for it or something. But I don't know if that's even like the right track for like trying to make the definition work for something like this. Hey, SPQ. Yeah, that's kind of like, that's like the premise of the question, I guess. But I guess you're supposed to, or I'm trying to think about like why, or actually like understand it. So I think if my memory serves, like these two do imply each other with if-thens. So if we were to say, if there is a closed pre-image, then there is an open image. But that's for continuity. So we need to negate it again? I don't know, dude. I'm getting confused in the logic. Not Q, not P. Ah, okay. Contrapositive? Okay. And so that's what I was trying to, that's what I was thinking about to try and make this function work with this definition of continuity. So that would mean if there is a closed pre-image, then there is a closed image, which is what we were running into here. For any closed pre-image, there is an open, or there's a closed image. Which I feel like is true without having to investigate it too much. Okay. How does this connect to the definition provided at the beginning? So I feel like all that work is just to understand what the definition is actually saying. Which I feel like I just have a sort of tenuous grasp on. So Stack Overflow? Yeah, sure, Zach. Just let me I'll bring it up, but I don't want to I don't think about it just a little bit more before I actually look at it. Function f, where limit is exponential to k of f of x equal to f of k. So I guess maybe the connection is we have to make an adjustment for the same reason, where because of this gap, we can't have the limit equals the value of the function. Well, actually, you only talk about one-sided limits with this function, can't you? Maybe I'll just look at the stack exchange thing. Prove epsilon delta definition of continuity implies the open set definition for real functions. Oh, wow, this person's a bro. Okay, so let's make it a bit bigger. If f is epsilon delta continuous, then it is open set continuous. Suppose f maps R onto R is continuous by the epsilon delta definition. Prove that it's continuous by the open sets definition. Take an arbitrary open set V is a subset of R. We want to prove the pre-image of V is open. Okay, yeah. Now they don't specify it's a proper subset, but I guess if this is a stronger statement, or maybe it's not going to matter. It's going to become a proper subset later on, or rather, like this is true for more cases. Like, I don't know. Let's just keep reading and see where it goes. They check the empty set case at first, but that's not as important. Okay. It's true if the preimage of V is empty. It says open and closed. Yeah, okay. So assume X belongs to the preimage of V. So if f of X belongs to V and V is open, there exists some epsilon greater than 0. Okay, wait, so V is our image. That's what I'm getting. For any open set in the image, we need to show the pre-image is also open. Okay. And so V is our pre-image, and it's open. V is open, so you find a random epsilon. You find an epsilon neighborhood around any random point. Okay. So if X is in the pre-image, f of X must be in the image, and it's open. So there exists some epsilon greater than 0 such that... okay, fx plus or minus epsilon is inside V. Okay, just using the definition of an open interval, open set. By continuity at X, there exists some delta greater than 0. Okay, yeah, epsilon delta continuous. So X minus delta comma X plus delta is a subset of the pre-image. Okay, that is X is an interior point of the pre-image. It's true for arbitrary X belongs to the pre-image. It follows that the pre-image is open. So I guess I feel like I understand very generally what this proof is saying, which is if it's continuous, then it's getting very like arbitrarily close to whatever point of interest you can name. And because it's continuous, or the image is getting arbitrarily close to your point of interest in the image. And since it's continuous, it must mean that the pre-image can also get arbitrarily close to the point in the pre-image. I feel like I don't really understand. I would need to think about it a lot more before I feel comfortable with like the mechanics of what's happening here. But that seems to be the general point of this. You can choose a random point. If you have a bit, no worries, Zach. You choose a random point, the pre-image of that point, that set, or the pre-image of a neighborhood of that set. The pre-image of a neighborhood of that set is an interior point. It's just saying that each random point is interior. That interior part is what I need to like. It makes sense, I guess, intuitively, but I feel like I couldn't really justify that for myself. Actually, I don't think it matters if they only test continuity on all proper subsets or not. If you prove the open pre-image for all proper subsets, you can write R as the union of them. Wait, are you saying it doesn't matter? And then you say that it does matter? I don't know what you're saying. You don't necessarily have to check continuity on all open subsets. It suffices just to check on a base of codomain, of a codomain. Oh, just Oh, okay. Not necessarily every open subset, but if you were to just cover every possible value once and then union them. Is how I'm interpreting that. Which I guess I don't know enough to like tell you that you're wrong, so I don't see what's wrong with that. Because the preimage preserves the basic set operations. Okay. Let's look at the reverse direction now. If f is open set continuous, then it is epsilon delta continuous. Preimage of union is the union of preimages, same for the intersection. Okay. Suppose f maps R onto R is continuous by the open sets definition. We want to prove that it is continuous by the epsilon delta definition. Fix x belongs to R and epsilon greater than 0. Then f of x minus epsilon, f of x plus epsilon is an open set in R containing f of x. Right? Without saying anything about that open set yet, we're just making some neighborhood around f of x. By continuity, U is equal to the pre-image of the image. What the hell? Okay, so U is going to be our pre-image. It's just taking the thing that we just talked about, f of x minus epsilon, f of x plus epsilon, and getting whatever x values, you know, your inputs that go with that, I guess. It's an open set in R. It is easy to see that U contains x. Then, whoa, 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 whoa. Don't tell me it's easy to see that U contains x. It makes sense. I don't know why it wouldn't, but I feel like that's kind of glazing over it. Oh. Holy crap. Andrew Chavez, thanks for the tier 1 for 3 months in advance. I really appreciate that. Subscribing during topology. Yeah, dude, that's how I know, like, you're a true, like, math enthusiast if you're interested in this, what's happening on the stream right now, I guess. Hey, Bob. U contains f of x. You remember studying this? Yeah, oh yeah, this is my first time. Oh, SPQ. Okay, thank you. I get it. Because f of x itself is included in this open interval, then the pre-image must include x in that same open interval. Okay, thank you. It wasn't easy for me to see that, geez. Then x an interior point of view by the openness of U. Hey, Scorpra. You do the multivariable analysis, which uses a lot of the same ideas. Is multivariable, like, that's what I assume topology is, where, like, we're talking about just, like, we're talking about, like, a number line or maybe a two-dimensional plane, but topology, you have, like, arbitrary dimensions. How's it going, Scorpra? And Andrew Chavez, I passed Calc 1 and 2 with C's. Well, hey, I mean, welcome in. are you still taking a math class, or like what's happening? Honestly, calc, or I mean, well, any class, but like I got a little bit lucky with calculus, where I took it at first in high school in grade 12, and the teacher for that I really liked, and that's where I like learned the basics. And then for some, for a stupid reason, that my advisor in college sucked, or university, I retook Calc 2, and I didn't like the professor at all. I wouldn't have learned much, but because I had already like taken it, I it didn't matter that he wasn't good. So we're working on UAVs now. Now I'm thinking of like unmanned aerial vehicle or something, or whatever it was in Call of Duty. I assume that, I mean, maybe you're working on those, but is that what UAV means? Going well, Scorpio? That's good to hear. Really? Okay. Well, that's super cool. It's all interconnected topology. Genesis much greater spaces than vector spaces. Okay. Um, accident interior. Okay, I only got like halfway through this. So let me like. I just got to this part. Accident interior point of view by the openness of view. Okay, just saying it's not an endpoint, I guess. That is, there gets a delta greater than 0, such that this is a subset of U. Yep. The image of x minus delta comma x plus delta is a subset of the image of f of x minus epsilon f of x plus epsilon. Huh. Within the Marines and now contracting? Ooh, wow. We can't mention use topology much, but so curious, like, what did you like study to like get into that line of work? I mentioned it'd be more like aeronautical engineering or whatever it's called. Whoa! Thank you very much for gifting Bob. Got me to 30 subs as well. Thank you so much for that, and Ander, I really appreciate it. I'm getting a little weirded out. So the image of x minus delta, comma x plus delta is a subset of something that is already an image minus delta, comma something that is already an image plus delta. So here, I feel like if we weren't working with sets, it would be an equal sign. Because the Marines like topology. Not me, but more power to them. Follows that. Huh. Everybody likes topology? I don't know about that, SPQ. Did I play the same alert twice in a row? By the way, I wasn't even paying attention. I'm gonna replay that to see what alert does. Okay, no, that's a different alert. Okay. I might have actually done the same one. I like the alerts are supposed to be random. I feel like it's some weird, really weird randomness though. Everyone likes that theory. Oh my god. Computer science, electrical engineering, the main things, along with what you said correlates the most. You went to school for computer science. Oh, okay. Yeah, I guess you need a bunch of different types of majors to actually get a UAV in the air and working. No, I don't know, man. The text to speech voices. Well, hey, thanks for the bit, but I don't, dude. Anytime I hear a text to speech voice, it really annoys me. Hey, Star SK. I'm doing good. How about you? I'm just doing some like studying right now, but I'm always happy to answer questions if someone in chat has one. But yeah, no, whenever I hear the text-to-speech voice in any context, it really annoys me. I just hate the way that it sounds. You're good too. That's good to hear. Done on the first stream after you got affiliate? What's that? Oh shoot, I missed your first stream after you got affiliate? Dang it. I've been waking up way too late, but what'd you do? So I mean, I don't know if I've really we've at least talked about this a lot. I don't think it's really sunk in the answer to this question yet, but I think I've gotten to the end of how much I want to investigate this right now. So you auto set your chat to sub only? Oh no! The toggle for that is super like casual. Like it's hard to like I've absolutely been like, oh, like, or it looks like it's something else. Oh, that sucks. You insured one bit. If your channel points are on, I think there's a default one to send a message in sub only mode too. Being turned off, yeah. I mean, to be honest, that's kind of a Chad move. The instant you get affiliate, you gotta be like, you gotta be a sub to talk in my chat. I don't want any plebs here. Flight theory / logic. Most of your experiences in flight line maintenance avionics. Wow. Yeah, I can definitely imagine how computer science would help with like, you know, obviously you have to make the you have to be able to plot out your routes and stuff like that, and actually like make the UAV do what you want it to do, I guess. But most of your experience being in flight line maintenance avionics. I mean, that sounds almost more like a mechanical, I guess, than computer sciencey. Which I guess it doesn't have to be good computer sciencey. Okay, so I was working on this before. Oh gosh. Oh god, yeah. Yeah, the good old sin x over x proof. I don't even want to look at that. Not yet, at least. Oh man, what did I do for this one? I remember I attempted this one. I don't remember I got an answer that I was that satisfied with. You probably don't remember it. I've looked at it a couple of times. I remember you sandwich x between sin x and tangent x or something like that, or like, you know, that's a hint that Zach gives here. I don't remember how you relate it. I know it's related to this triangle that you have to draw. I just don't remember exactly how. I might try and investigate it, but I think I'd rather do the earlier ones. Computer science just helps you with the avionics portion. Ah, okay. Is that did you like actively try to get into working on UAVs, or do you like end up there just out of curiosity? Okay, think about the limit as x approaches a of x squared, and up there with the Marines. Oh, okay. Well, either way, I guess as long as you're enjoying it. It does seem like it'd be very satisfying to actually like have worked on something and see it actually do the thing that it's supposed to do. So I remember I was working on this limit as x approaches a of x squared thing before, and I might have been making it too complicated because today in class we did a little like epsilon delta proof just for a constant function. Oh, holy crap. Ender, you've gone mad. Thank you so much for the 5 gifted. Holy crap. Who got them? Sate, Polylagrangian, Hanlon, SPQ, Kyle Effect. Wow. Thank you so much, Ender. That helps me out a lot. And Ricky Physics, thanks for the follow. You love the idea of my stream? Well, thank you so much. It's something that's really fun that I'm trying to like well, not only me, but I'm trying to like, you know, grow and become more of a thing. I'll finally be able to pay my rent. I mean, in California it's gonna be a bit longer for that, but well, thank you so much, Ender. I appreciate that. And I don't mean to advertise to you, but if you're interested in more math streamers, there's a good list of them there. Who all do like math help streams, so. The math community on Twitch exists. It's small, but it is out there. And I don't know, I really like the idea of being a place where students can like get live help like this online. So I hope that it can become a thing. A random boom of math streamers. That's kind of the hope. So that's gonna be a super cool job to actually have. Maybe we can call ourselves OGs. Yeah, hell yeah, Bob. So if we want to do an actual like epsilon delta proof here, we'd want to have x minus a less than delta, and x squared minus a squared less than epsilon. And I think I was doing some fancy business with saying x plus a times x minus a less than epsilon, and then dividing by x plus a. But could we just take delta equals like root epsilon or something here? Like, was I overthinking it? I need to look back at what we were doing in class. I want to look at the epsilon delta that Obi did for a line. Which was up here. Oh, it's a little too zoomed in. I want to look at this. Well, are you saying that we're not gangsters, Bob? I feel like a gangster. If almost x approaches a of f of x and limit x approaches a of g of x exists, then something good happens. Oh. That's smart, SPQ. Oh, I get it. As in group theory. I was just taking group as a generic word group. Yeah, is there a different one? I mean, group is, I guess, the perfect word because it's still it works in both like contexts. Is your tag for best beard on Twitch is more accurate? Yeah, I mean, ever since you shaved, the competition has gone down. Okay, so if we're going to use SPQ's idea here, how many elements are in the group? I guess it depends on how you count. I don't even know for myself. If it's anyone who's streamed math, it's a good, like, 15 or so, if I were to guess. I'm going to take that as self-evident, even though I haven't done epsilon delta proof for that, but... Then, limit as x approaches a of x times limit as x approaches a of x is equal to a times a. And then by limit properties, okay, so I mean, if you just use limit properties, that proof is a lot easier than trying to do an epsilon delta. But I feel like we're supposed to do an epsilon delta. A cyclic group of order 7? Original geometers? Yeah, no, I'm definitely a geometry disliker. You're the neutral element? I mean, I just have is it 7 now? I don't even. One, two, three. Oh yeah, 6 and then plus me. But there's quite a few more math streamers than that out there, so that's why I said it depends on how you count. Hey, Zach. So I was just looking, I just went back to the Tuesday's notes. And I was looking at problem 6 again. So I think I worked on it on Tuesday, but hey, Budib, you're first, yeah. You want to eat fruit? What kind of fruit? Yeah, so again, problem 6. SPQ pointed out like a much easier way to do this proof using properties of limits that I think are within the confines of what we've learned in class. But I imagine the intent of this is to do an epsilon delta proof. Bunch of kinds. Let me think what you want the most. Okay. Original Gausses. That's good. Okay. So I do like that, and I think it counts, but I think we're supposed to do it the hard way. Just to flex our muscles, I guess. Well, I mean, have we done that for continuous? I mean, we've done it for sequences. I don't think we've done it for continuous functions, though. That limit property. Prefer to cheat whenever possible. Me too. Okay, so if I try to struggle through this epsilon delta, again, we'll have x minus a less than delta, x squared minus a squared less than epsilon. And so we were to do what Obi called the discovery phase. You want to sweet sop I have to look that up. A sugar apple? That sounds delicious. Some melon and some sugar cane. I've never eaten do people eat sugar cane? I never knew that. It probably would taste pretty delicious considering it's sugar cane, but so if we were to work with this and just try, I mean, either way, I guess that this is what I was doing before. Where do you take it from here? You gotta bound x plus a, I guess. Fun fact about this proof, when you first downloaded and learned the basics of LaTeX, the proof was the first thing you wrote as a test? Oh, cool. Do you do it the epsilon delta way or the limit property way? Epsilon delta? Okay. I don't, this is the thing. Okay, no, so wasn't the proof of the line where this issue came up? It was the rational function where we were trying to like bound certain things. X is supposed to be close to A. Could we say that like X plus A is less than 2A? Well, no. Maybe? No, because it would need to be 2A, like, it has to be... It's only true if X is approaching A from the left. If X is approaching A from the right, then you're over to 2A. There's one cool trick you need to think of for this proof. Oh, God. First thing you wrote in LaTeX was a schizo text I sent my high school teacher about points on a circle and some theorem I was trying to prove or something. Okay. So you know the hint? Let me think about it a bit more. You could triangle inequality. I don't know if that really helps you though. I don't see necessarily how it would. All right, fine. Tell me the hint. X plus A is equal to X plus A, X minus A plus 2A. Oh. So where would we want to do that? We need to work out how to use that hint. I guess maybe over here and then we triangle inequality. Well, okay, it is. Well, Bob, you might need to see a doctor. That's a crazy sneeze you have there. All right, so if you triangle inequality, this but we don't know how this compares to epsilon, right? So maybe it is after we divide it that we want to use that trick. You know how to draw figures. This hasn't really changed, so I described everything like the Greeks would. Oh gosh. The reader might suffer, but the writer affords a peace of mind. So Would it help if we divided by that first and then... No, because then we still have the same issue with the inequalities going the wrong way. Being proficient in it seems a bit much. I think LaTeX is good. I don't really know it that well though. Do I have the inequality going the right way here? Because I feel like I'm just stuck here. Oh, I know. Okay, I never heard of ticks, or I don't know if that's how you're supposed to pronounce it. You don't have the inequality to begin with. You just want to have it. You just want to have it? Okay. So let's maybe forget about some of what I just did. Let's just consider x plus a times x minus a and forget about epsilon for a little bit. Okay. And I assume we want to factor in absolute value x minus a out here. Wait, it already is factored out. Never mind. Did I do something wrong here? 1 e4 e5 first. Between you we can pretend like you're first. welcome. Struggling to write carefully coherent argument for the CSC thing. I would too. If you find delta small enough that the right hand side is smaller than epsilon, then it'll be smaller than the left hand side. Wait, Buddha, are you 1 e4 e5? Okay, yeah, I was like... Of course, that's your YouTube name. Neither confirm nor deny? Oh, yeah, sure. you can find a delta small enough that the right-hand side is smaller than epsilon, it'll be smaller than the left-hand side. Find a delta small enough that the right-hand side is smaller than epsilon. Be smaller than the left-hand side. Well, yeah, I mean, I'm betting that delta is going to be root epsilon. I just don't know how we like are supposed to get there organically. Am I nearly there? It's not? Do I have it reversed? Epsilon is root delta? I don't know. Just say it exists. Do you do some kind of, like, can you do some kind of inequality thing here if you write it like this? And like, I want to somehow chop off this 2a x minus a. Which this entire thing is less than or equal to? I don't know. No. That's backwards. That's backwards. It's not true. Dude, I don't know. Gonna DM you. Okay. I'm completely lost on this proof. Okay, so same setup here. Wait, you can just let this be less than epsilon? If it's less than epsilon, then right? How does this help us? I don't see where you would go after this, because isn't this doing, aren't we just getting back to x minus a, x plus a less than epsilon? It's like, I thought we already have. Well, yeah, but like, is the point of this last line, hey, hoo-hoo, how are you? Is the point of this last line that you are going to get it back to be x minus a times x plus a is less than epsilon? Because that just, we're back where we started. Then what's the point of doing this? I don't know. I don't know what you're doing with this, Bob. Okay, yeah, sure, Bob. Okay, I'm on push to talk. Oh, I see. Oops, wrong one.
Hello.
Hello?
What's up?
Nothing much. How about you?
Nothing. Taking a break from studying to do more math with you. I'm a genius.
Oh, yeah. Okay. I believe it.
Okay. Okay, let me try to share the screen, right? I missed the class, but I am making up with this right now. Sorry, Zach. Uh,
Yeah,
okay,
it's
so
like a makeup test.
yeah, so we have this. Right, let me I haven't used this in a while. Smaller than epsilon, right? We have this part.
Right.
Sure. And we want to find delta greater than 0, such that if x minus a is smaller than delta, then this holds, right? Okay, I'm just doing everything, step by step, so everyone is following me. So let's expand this bad boy, as you did. That's x minus a times x plus a smaller than epsilon. I'm just gonna ignore this smaller than epsilon for now, actually. Just so my idea is clear. This will be x minus a times x minus a plus 2a, right?
Right.
So now I'll enlarge it a bit by doing this triangle inequality that we showcased. X minus a is x minus a plus 2a, right? So like the idea is, okay, I have enlarged it a bit, and like maybe I enlarged it, right? And if I can show that this is smaller than epsilon, then this will automatically be smaller than epsilon, right? So the idea being like I can enlarge this part as much as I want, as much as I get like that the last enlargement is smaller than epsilon somehow, I'm still fine.
As long as well, whatever we're given, we have to find the delta, don't we?
Yes, we do. So
Okay.
we want to find delta such that this inequality holds, right?
Okay. Yeah.
So let's say we find that delta, right? So let's say we have some delta such that this inequality holds. Well then, like in the process of finding it, this is why it's like scratch work, then this would be like smaller than delta. We just substitute delta in instead of x minus a, right?
Okay.
Delta plus
Oh.
a, right? So now, if I can make that somehow smaller than epsilon, I'm chilling, man. Because if I can get this, then I automatically get this and everything back.
Okay. So do
Can
you have to
you?
solve this for delta now?
Hmm. Exactly. And it will get much messier than square root of square root of epsilon, because now
Yeah,
you
because you got
can
a
get
quadratic
like
formula, right?
yeah plus uh 2a delta minus epsilon is smaller than 0, right? So what do I want? I know that this guy is looking like this, right? Let's say.
Yeah.
I actually don't know where the line is. So I want to find, my idea would be, like I can find 2 points, 2 null points, and pick any point in between here.
Okay, yeah.
And in that way, this inequality will hold and everything else will hold. Like I think that's a good way to do it. So how do we do that? We do the quadratic formula. Or if you're really good at Vietas, but I don't.
Oh, I know I'm not.
Yeah. So that'll be 1, 2 would be equal to minus 2a plus minus square root of would be b squared would be 4a squared minus for epsilon. I think that's right. And over 2. And another important thing that we note is that the delta must be bigger than 0, right, by definition.
Right, yeah.
So the only way to ensure that it's bigger than 0 is we take the plus 1. The other one will be smaller, right, because we have negative minus negative.
Right, because yeah, the square root has okay, yeah. That makes sense.
Yeah, and this guy inside would be right, just like 2 square root of a squared plus epsilon, which would be, of course, bigger than 2 square root of a squared, which is 2a, right? So we ensure that it's larger, that this is greater than 0. It's another important part.
Wait. Okay, so okay, I see. You can say that delta is greater than 0. Is this?
Yeah.
Do we need to actually name the delta though? Or I guess that is
sorry,
our. I guess that is how we name the delta. We just take the plus.
Yeah, we need it to be positive,
Okay.
and it to be somewhere in between, right?
Okay,
Like
so yeah,
somewhere in between those points.
and so that plus is your choice of delta, and then you're proving that that delta is indeed like positive.
Yeah. I mean that's our like null point, right? Like it's kind of messy with notation. We're abusing notation really much here, but I think that's what we're trying to get. Like if we simplify this would be like minus a. Just if you take out the 2 and divide, you get minus a plus square root of a squared plus epsilon. Right, you just take 4 out of the square root and divide by 2 everything.
Yeah.
So you want to pick some point between minus square root of a plus square root of a2 plus epsilon and 0. Right? You want some point in here for this to work because that will be somewhere around here, I think. It's somewhere in here with that point gonna last, and delta will not be.
Well, I speak of saying that you can just do a different thing too that saves you the quadratic formula. I don't know what that last step that you just did was.
Yeah, I mean
But-
that's the way I did the proof.
Yeah, no,
I
this makes
so,
sense to
so
me
I'd
too.
say like I can just take that this is my delta, like I can define a squared plus epsilon over 2, like it's oh wait, I'm stupid. Wait, don't hate me, guys. Don't hate me, guys.
I mean, you got way further than I did, so
0 minus a. Yeah, that is positive. There we go. Yeah, so I can just pick that, and then the whole inequality will hold. Like you just pull it back here, which will pull it back there, and just goes all ring around the rosy, kind of a. So that's one thing that I was talking about. Like my first like lecture and proofs that we did, the professor like, oh, proof for this is just you pick delta is this and it works.
Oh, good.
Like I see it works, but what the hell?
Yeah, where you get it.
How am I supposed to know that? Now, if you remember, like all of our talks during the analysis courses.
Yeah, yeah. It's a common thing.
Yeah. But yeah,
All right.
that's it. I'm gonna go back to lurking if you
Yeah.
understand everything.
Thanks
Questions?
for showing me this. I think I'm gonna maybe try and like repeat. Can you show me the beginning part? We're beginning with the triangle inequality because I kind of want to repeat the argument with what SPQ is saying.
Yeah, there. So like, I make this smaller by triangle inequality, and I make this smaller because like I want my delta to be that. Like if my delta satisfies this condition, then this inequality will hold.
Yeah, I think instead of like in that last inequality where like the delta times delta plus epsilon value 2a, they make the delta less than 1, and then they have delta times 1 plus 2a less than epsilon. I'm not sure exactly, like I that's why I want to like actually like write it out so I can see how it works, but
I'm not sure like why delta should be less than 1.
it's just like an arbitrary thing. If it's greater than 1, you or equal to 1, you take that case separately.
Oh yeah, maybe because then. I mean, you can, and then like minimum
Yeah, yeah. That's what I'm saying
of those
exactly.
two, but like I'm not sure if it's required.
I think it's just a way. I think they're both valid. Just it maybe the other way is a bit more like approachable without doing the quadratic formula stuff.
Yeah, maybe.
But thank you for showing me this way too, because that's the way that I was like trying to like engineer something. I didn't realize it involved the quadratic formula, but that's what something like what I was imagining we would get. I just didn't know how to get there.
Mm-hmm. Well, if you can show what you mean on stream, I'll go back to lurking.
Oh yeah, sure. Thanks
And
for
enjoy.
showing me this.
Yeah, see ya.
Bye. All right. Isn't it a unique way to choose delta? Yeah, so I think they're just saying a different way to choose delta that it's maybe more in line with, I guess, how we have done some of these other proofs. Okay, so I screenshotted Bob's work up to the point where this diverged. Well, actually, so, my gosh. I have that too. And then we still do the triangle inequality there, but we don't want this. Instead, since x minus a is less than delta, we can make a new inequality that's delta plus 2a times delta. And we're taking this to be less than epsilon. I don't know if I feel like that feels kind of weird to me, but let's just go with it. And then what SPQ was saying is we're gonna take delta less than 1. Then I should write it more off to the side. So the delta on the inside we just set to be 1. We keep the delta on the outside. For whatever reason. I should get rid of that epsilon. So it's an epsilon. Which implies that delta is less than epsilon over 1 plus 2a? And that's our choice of delta? Okay. Or 1. I guess. I assume we just do 1. If we're taking delta less than 1, then if that's greater than 1, then we just take 1. I don't know. This whole min thing is really weird to me still. And is this the proof or is this a scratch work? I don't even know. Let me look at it. I think it's the proof because we have chosen a delta. To get delta subscribe for 6 months. Yeah, it is. First month alpha, second month beta, third month gamma, and then the next jump is at 6 months. I was assuming I don't know why you ever need the min or not. That's part of epsilon delta proofs that I'm confused on. So I just put that on there because I've seen it on other epsilon delta proofs. I don't actually know if you need it or not though. Hmm. But like, okay, so yeah, the assumption that we made with delta less than 1, it would break that. But why 1? Why not say 0.01? Do we know that 1 would work for any epsilon that breaks the case? I don't know. This is kind of related. Or this, like, we're doing a rational function problem that was just like the one both real numbers, weren't we? I know 2a is a real number, but... Oh, we didn't have to actually prove it, though. At e to the 2i pi. No, I forgot to charge my phone. I literally thought to myself before I started the stream, oh, let's put my phone on the charger before it starts. So this exact thing doesn't happen again, because it happens literally every stream, because I've been doing math for a lot longer. Okay. Frickin' hell, dude. I need a real camera, but that's a long ways off. I should actually look at how expensive a camera, like, is. Write 1 instead of Zach, or instead of 1 you write Zach. Yeah. Is there anything else you want to look at on this sheet? You know what? Oh gosh. I just want to look at the limit definition of function, because this is the first time we actually provided the definition from Zach, I think. For any epsilon greater than 0, there is a delta greater than 0, such that when x minus k is less than delta, then fx minus w is less than epsilon. And so that's why when we've been doing this, we work with f of x minus w is less than epsilon to kind of like do the discovery, as Opie's called it. The thing we actually need to name is the delta. Let me look back at the, so I think we worked out kind of this proof in class on Tuesday, but starting to run out of time and we glazed over it at the end. Maybe I should try to reprove it, because I definitely don't remember it. So for number 5 here, limit x approaches 6 of 1 over x minus 4 is equal to a half. So yeah, we started with this. So I was just playing around and getting a common denominator. Can take a 1/2 out, multiply by 2, split up the absolute value to be based on the fraction. And this is where we use the same argument, where we just take delta less than 1, consider only that case, then x minus 4 is less than 3. Oh. That I'll send by it is perfect for real analysis. Hmm. What happens when x equals 5? Well, I think in this argument we were making it less than 1. So when x equals 5, it's equal to 1. I don't know what happens. Maybe let's get this in paint. Oh, for like, you're saying that this statement isn't true? We weren't showing our work very well, but I should say I wasn't showing my work very well, but this was only for delta less than 1. This statement. We didn't actually say that though, Zone Ranger. To your point. What's the problem again? One over x minus 4. What an annoying song. Oh, that's the end of that playlist, isn't it? Let's go there. Okay. Phone, are you awake yet? Okay, so get the common denominator again. Oh my god, it is pouring outside. Holy crap. Love to see it. Okay, sorry. Final limit of sine of 1 over n. I think it doesn't exist. It fluctuates too quickly. I don't remember, or it's something super weird like 1. I I don't remember the answer to that. I've seen it before though. It does go to 0? Okay. I just remember it's one of those super weird ones. I guess 1 over n wouldn't... Well, I don't know. Yeah, that's fair. That's what I was thinking about in my head, and then my brain started to hurt still with whether the sequence is still gonna have super weird behavior. So, so wait, just to check what Zone Ranger is saying. It's not less than a third. It shouldn't be. Delta is the minimum of 1 comma epsilon over 6. Then epsilon over 6 is 1/18th. I don't know. I see that I had a reply on Reddit. Let's see what that reply is at least. This is this still isn't a real world example because each gas station is gonna have its own price. But you have to fill up your tank to capacity. Would make it be different as well, but that's not in our control. To do the problem as it's stated, then I think you can So gallons of gas needed for the trip. Still do... Yeah, exactly, SPQ. We basically need a ceiling. I haven't like gotten there yet, but I think that's what it's going to end up being. Required. Then divide by tank capacity. Get the number of tanks of gas. Likely a decimal. Then round that number up to represent filling the tank up fully. And then you would do total gallons required. That's the amount of gas that you're buying. And so then you multiply by the price per gallon and you're good. Yeah, SPQ, that's the exact like issue where like when do you draw the line at realism versus just having a solvable math problem? But that's all in the students' control, so I'm not really gonna give them crap for it. Okay, so what I have written here is what you have inside the ceiling, so we agree so far. Then round that number up to represent filling the tank up fully. Rather, like, what I've done here is what you've written out with the ceiling. Then you're saying to multiply by capacity again, times price per gallon. Why are you multiplying by the capacity again, SPQ? The number of tanks of gas. Because I was thinking that just from once you know how much total gas you're gonna buy, you just multiply by the price per gallon. Unless I'm not following my own math right. You do miles over miles per gallon gives you gallons. And then you have tanks required for the trip, right? So you pay prior to the trip. Like for accounting for starting with a full tank of gas? I don't think we would factor that in. I don't know. I guess that's up to the teacher though. Divide by the number. Otherwise, you have to subtract 1 from the ceiling. No? The ceiling represents you only, like, you know, if on your last stop you only need half a tank of gas, you're still going to buy a full tank of gas anyway. That's what I was thinking the ceiling represented. What if you can finish the trip on a single tank? Okay, fair. I guess, okay, yeah, that, then it would make sense to include something, right? So maybe you do include starting with a full tank of gas. How are you with differential equations? Ordinary differential equations I'm decent with. Partial, I don't really know at all. I learned them a tiny bit, and I've forgotten most of that. Like, I'm comfortable with first order stuff. Yeah, sure, Bob. So if I change my mind and I do want to... okay, let me... Miles divided by miles per gallon gives you gallons. Then the tank capacity will give you number of tanks. Ooh, Laplace transform. I'm gonna have to relearn those. It's been a minute. You said the integral from 0 to infinity of sin x over x is equal to pi over 2? Okay. That's the number of tanks we need. So we need to convert the number of tanks back into... Okay, that's why we multiply the capacity again. Required, multiply by the capacity of the tank to get the gallons of gas required. Okay, I think I understand this now. Multiply by the price per gallon to get the total cost. But all in one, we have cost equals I'll use the ceiling thing. Distance over miles per gallon times capacity times capacity times price per gallon. With seal, the seal part means to round up whatever is inside the parentheses, called the sealing function. Perhaps subtract 1? Do you think so? I think we do account for starting with a full tank of gas based. Okay, so if you're going to do the trip in 1 tank of gas, that means that whatever's inside the ceiling is going to be some kind of decimal between 0 and 1. Yeah, sure. Usually let me put this up there. Yeah, after thinking about the case where like the trip is just 1 tank of gas, yeah, it's not necessarily clear. I could add that as a note. Start with and pay for, or that you pay for a full tank of gas before leaving. So if the trip takes less than 1 tank of gas, we're still paying for a full tank. And is that actually true? If our distance is 10 and our capacity is 20, whatever's inside the ceiling is surely less than 1, but greater than 0. So it gets rounded up to 1. Then you multiply by the capacity again. Yeah, I think this works. But in most cases, your capacity is going to be less than your distance. Okay. I think this is okay. So let's look at your Laplace transform. Your Laplace transform of sin x over x is pi over 2 minus arctan s. I learned Laplace transforms and I remember enjoying doing them. It's been a very long time though. This is the definition that we need. What is the S again? It's just the variable. Okay. Hey, Castle Bravo test. How's it going? Actually, can I get my big cam back up again? I want to go to the whiteboard for this. Yeah, I'm just doing some math for fun right now. It's going good. Normally I prefer to work on like homework help questions, but there aren't always questions out there for me to do. So we fill in the time with still studying whatever sounds fun. And No Pro Bob gave me a question on Laplace transforms to see if I can do it. 779 RM. I shouldn't have said that out loud. Let me get a new link. It is so hard for me to not say. I don't know if that's. I probably shouldn't. Yeah, no, I definitely shouldn't leak that URL. Okay, new link. 1 minute. Don't say it out loud again. You guys won't be able to see it yet. Oops, purely mathematical question, or is it a question in engineering? I think purely mathematical. Is there an engineering way to do a Laplace transform? I only I learned in the context of like a normal math class without engineering involved. Sorry, I'm just taking a minute to get my big camera set back up. How does that look? A little misaligned, right? That's as good as I'm gonna get it right now. How you ought to solve it? Oh yeah, like I doubt the table can be used, or I doubt the table's gonna have sin x over x, but I don't think a table goes against the spirit of the question. The question is sin x over x. So I was planning to just use this. I don't know if that's gonna be a good idea or not, but I guess let's see how it works out. Oh, actually, the question is actually prove that it is. So, I mean, maybe because the table, or okay, that's yeah. So I guess it would be against the spirit of the question to just use a table for the end result. But if there's some kind of way to break up the integral and use a table for part of it or something, then that I think would be still in the spirit of the question. But I think we are supposed to like prove it though. How do you draw the fancy L? Like that, I guess. Or not find, but show. Actually, so yeah, we are actually given the end result, aren't we? Oh, so you literally can't integrate? That's true. I thought that the E would come in handy here. But what you're saying is that you can integrate. Okay. And the hint that you gave is, oh, let me write down the hint. Pi over 2. Okay, so let's apply our definition of a Laplace transform, I guess. And just see how that looks. So e to the minus st times sine of t over t dt. Now, if we're going to use this fact, I assume we integrate by parts. And we're going to take u equal to e to the minus st, du equal to minus s e to the minus st dt, and then dv. No. No. Your squiggly brackets are a sight to behold. Thank you, Castle Bravo. I really pride myself on them. Just wonder why L is a unique function for which the parameter... Well, isn't it an operator? Or it's not a function on its own, is it? Because it acts on other functions. I don't know, though. So I was going to say that we want to integrate sine t over t, but when you integrate by parts, it's actually like the indefinite integral when you do that, and we don't know that for sine t over t. We could derive sine t over t. I take that as our u. I don't know where that gets us. Don't even try it. Wolfram Alpha? Okay. You know me. If the Laplace transform is a transform, it takes a function and transforms it. Yeah, Castle Bravo. I assumed it wasn't like a function, it's something else. Well-defined function, function transformation, map, it's all the same. I don't know. That's beyond my knowledge, at least. So... I mean, the only thing I can see to do is integrate by parts. So let's try it the other way, where we derive that. Quotient rule. That, we're gonna have to integrate with that, aren't we? Terrible, no. Just making sure that it really is as terrible as I think, and I think it is. Maybe it's even worse than I think. Okay. Could we use the complex definition of sine? That would give us something that maybe we can integrate. Don't do complex for your sanity? Okay. So we have some other trick that we can do, I would guess. I don't think integration by parts doesn't seem to be it. Or at least not in the way that I was doing it. We could try like rearranging it and doing integration parts with different combinations. We don't have to do it with e and then sine t over t. We could do it with like e to the minus st over t and sine of t. I just don't see what else to do besides integration by parts. But I assume there is something. Do you have to square it? Is it like the like, okay, maybe I'm going completely off my rocker, but is it like the Gaussian integral? Your friend told you one word and oh my god. Like, do you do something crazy? Or I guess... That's not exactly how the Gaussian integral goes, but we're not in the same form, do we? Hey, GleekWeb. Over on YouTube. Randomly popped up in your recommendations. I remember doing something like that in school, and then during your first year at uni, they think you wouldn't solve it. I'm right there with you. I did this during university, and I've forgotten it. I've been challenged by no Pro Bob to try and figure it out. It doesn't seem like an easy question so far. But welcome in, though. Thank you for being here. Gonna take a quick shower. All right, Bob, sounds good. I guess I'm gonna continue down this whole squaring the integral path. Because it seems like it'll give us some identities. The exponents will add, so minus 2st sine squared t over t squared dt. This doesn't really give us the identities. Well, no. For some reason, I was going to get a t squared, I guess, in the exponent for e, but we don't. And if the word is series, I'm going to be mad. Even though Bob is taking a shower and probably can't hear me. Huh. Yeah, I see. I seriously like. I don't think this gives us any. I don't think squaring it is gonna help. It feels like some really weird integration technique. Complex Fourier series without being one. Yeah. I learned a very tiny bit about Fourier series. Is this odd? It's probably odd or something stupid like that, right? Or even. Is it some kind of symmetric? E to the t isn't odd though. So I think it's gonna, I guess it's breaking our symmetry. Govan, nothing much with me. How about you? No, so we don't have symmetry here. Wow, that's quite the range. Yeah, the alternate forms look kind of nice, but they're complex. And actually, e to the t over t, can you integrate that by parts? You're going to end up with an e times ln that you have to integrate, and I don't know how that works. Okay, if this is Feynman, then I think Bob hates me. How does this work again? Yeah, Gleegleb. Basically showing the Laplace transform of sine x over x is pi over 2 minus arctan of s. And the hint that we're given that we can just use a fact is that the integral from 0 to infinity of sine x over x is pi over 2. And I have no idea how you go about evaluating this integral if you just do the usual definition of the Laplace transform. So I'm just trying to figure out some kind of integration technique we could use. And so I'm thinking just like some crazy stuff like Feynman integration. Hey, sine x over x. Go the other way, differentiate and morph it. That's true. You could do the inverse Laplace of the right how do you define the inverse Laplace? The inverse Laplace not have a formula? They're just using the table and doing it backwards in this one. Oh wait, differentiating and morph it into the integral you started with. Oh, I guess actually like I see what you're saying now. I was trying to look for an actual like given formula for the inverse Laplace, but you're saying just take the integral, or you know, say that we're trying to show that that integral is equal to the right-hand side and just deriving the right-hand side. How would that work? Because like the plus transform have the weird thing where you integrate in terms of t, and unit function is now in terms of s. We could derive in terms of s, but we never get a t involved. What's the derivative of r tan x is 1 over 1 plus x squared? Which, I don't know how that would work. Oh, wait. Healthy professor didn't believe in having students memorize complex integration techniques. Oh, God. Yeah, and the e to the minus st being inside the integral makes it... I don't know really how you deal with that. Hey, Bob. Is this Feynman? That's what you reduced me to, trying to remember how Feynman integration works. Wait, this looks familiar. It's Feynman! I literally just noticed this. Ah. I've heard of trick, but didn't know what it is. I'm more or less the same way. I know you integrate by deriving. And then oh, you had it on, that's right. That's so mean to put that integral on an exam. 2 out of 25 points. It could have been 0, I guess. I don't know. H prime of t. Wait. If h of t equals this, how does h prime t equal that? You passed the exam of the verbal exam. Oh, hey. I guess it didn't end up mattering. Wait, how's h prime t this in 1 minute and then... What? I might need to find a different explanation. This is super weird. It involves complex integration? Oh, okay, that makes sense, Castle Bravo. What's up, Bob? Do I have e to the minus tx? Oh, the derivative in terms of t. Oh my god. I thought they're deriving with respect to x. That makes so much more sense. Why didn't they said just h prime? I guess it's h prime of t, so maybe that's why I should have known it's the derivative in terms of t. But there's two variables there. Oh my god. Okay. Okay, you end up with h prime of t is equal to that minus 1 over 1 plus, or minus 1 over 1 plus t squared, and now you have to integrate. Well, what's happening here? Yeah, okay, so you integrate this, which becomes arctan, and you get the concept of integration minus arctan. Hey, Fratch? I have no idea how you're supposed to say that, but is there an argument for derivative integral is integral derivative? I just assume when the integral's in terms of x and the derivative is in terms of t, so I assume they're interchangeable. I don't see a reason why they can't be. I don't know though. I don't have a very like rigorous knowledge of calculus like that. If someone understands it, please help. Okay. What is happening here? Okay. So the Laplace transform of just sine is 1 over s squared plus 1. Someone solving it? Okay. And then the Laplace transform of x sine x. Oh god. It's still the same thing. And then if you... Wait, what happens to your other x? What? This third step is... It's lost me. This x magically goes away and becomes the minus d by ds? And I'm not even thinking yet about this, yeah, integral thing over here. You integrate both sides by that, really? Okay, so that's how you get to this next step. But why are you... I still don't get how the left-hand side becomes this. the right-hand side, I can see like you go from x sine x over x to minus ds. Yeah. The case of the missing x. All integration is magic. They actually did do the Feynman, just bad notation. Yeah, I think that's what that 0 is. That's where I'm assuming is where the Feynman kind of came in there, or something. I don't know. What you think the third step is? Oh, you might be right. You're just integrating and deriving in the same step and trying not to change the value of the integral? I guess that's where the missing x goes. Because when you're deriving in terms of s, that x from the e comes down in the minus sign. I guess that must be it, Bob, yeah. Oh, it's lagging? Why does it do that? No, it's not just you, Castle Bravo. I have no idea why it does that. I'm gonna have to Google it. I'm just gonna pause the music so it's at least not being annoying. Because it's on my end, it sounds completely fine. So you guys don't tell me. I don't even know, and I don't know why it tends to skip like that. Yeah, it does seem like a property of a Laplace transform, right? Or something. Or it's a lot of unexplained steps. Like that's not that. I think it's implicitly using this. Yeah, I think it's. If you derive that, okay, well, let me, being bad with the x's and the t's. Let me just do a new line. E to the minus st. Let me do x's because that's what the solution uses. Sine x over x is equal to infinity dt. If you derive that in terms of s, you get minus. I'm not. It makes sense in my head. I can't actually like show it in writing apparently, but it has that without actually showing it, they're deriving that integral. L of x sine x over x is equal to e to the minus sx, 0 to infinity, x sine x over x dx. And then if you do the d by ds of each side, I don't know if this notation is quite right, but it's something like this, I think. You derive that the minus x comes down. Where exactly is because we're gonna get x sine x, which I don't really quite get. Maybe I need to do it in the reverse direction. I need to start. Oh my god. Okay. If I just consider this in a vacuum without that. God damn it. It makes sense generally in my head. I can't actually make the mechanics of this work though. But I think the point is that you end up with integral e to the minus sx times sine of x, because with chain rule, a minus x came down, dx. And that, we would say, is equal to minus d by ds Laplace transform. I don't know exactly. It's some conclusion like that, but I'm getting a little bit stuck on how they actually do it. Can we rather for LaTeX? Probably. Oh, let me see what you sent me, Bob. Same thing. Well, I couldn't actually like make it work though, but were you able to get it like exactly right? To go to that, then you do d by ds of each side. Okay, so yeah, the key was to do it in reverse, I guess, and you end up with that. And not cancel the x. Okay, that's where I was getting stuck. So I was like nearly there. No one should. Yeah, that really sucks. If only I was a good mathematician. Yeah, every real mathematician does Feynman for every single integral. Just how it works. Some proof of the Gronwall lemma. Never even heard of that one. Hey, you know, I'm always happy that I figured out that it was Feynman. You needed to prove the Picard theorem. Oh, I remember learning about Picard. What does it say again? Oh, existence and uniqueness. Okay, yeah. You need Feynman to prove this? Picard Lindelof? Oh. No, yeah, I think I was looking at the right one on the other page too. The other Picard theorem up here was something completely weird. Okay, I don't remember that much about it, but I remember learning about this. Didn't really need Feynman to show it though. All right. 4 minutes ago, I blinked on a review assignment. See if we can give them some help here. Solve the equation for y in terms of x and z. Can certainly help them with that. The graph of the function y equals f of x is shown. What is f of -3? Can certainly help with that. Jorge or George, depending on your persuasion, cut a 40-inch rope into 3 pieces. The first piece is 18 inches long, the second piece is at least 9 inches long, but no greater than 15 inches long. Oh my god. Which inequality represents the length x of the third piece? Well, x is equal to 40 minus 18 minus whatever the second piece is. Maybe it's easier to do this in terms of the second piece and then try and get x involved there. I don't know. I guess it's probably easier to just do it more intuitively than trying to do it algebraically like I'm thinking. So the first piece is kind of irrelevant. We have, for all intents and purposes, a 22-inch length rope, which means that at the longest, we'll have 22 minus 9 is 13. And at the shortest, we'll have 22 minus 15 is 7. So I'd go with A here. Okay. So we can give them hints for these 3 problems. Start by adding z to both, or I would start isolating y by adding z to each side of the equation, then dividing each side by 2. So just leave that at that, there for now, and then we'll go to the second one. More. F of -3 means that you look on the x-axis, the horizontal line, the horizontal one, or where -3 is, then f of -3 is wherever the curve is. -3 line. It's kind of a hand-wavy way to explain with the -3 line, but the third one is a little tricky. The total length is 40, but the first piece is always 18, right? So we can just pretend we have a rope of length 22 and look at the different possibilities of splitting it in two. At one extreme, the second piece is 9 long, leaving us with 22 minus 9 equals 13 length left over for the third piece. This is one part the inequality. I'll leave the other part to you. It's done in a similar way. All right, let's do. I gave them a start for all three of these. Let's see what they say back. What the heck? Find the inverse function? Why would you care about this? What does that mean? The inverse of the arc length integral equation. Can you just find the magnitude of R of U? R prime is 645, but you do have to derive it first, then find the magnitude, then integrate it, as far as I know. Yeah, Bob. And I assume that's where they got the root 77. So that's 36 plus 16 is 42 plus 25. Isn't that 67? Wait, 64, 16. I did that wrong. No, 6 squared. 36 plus 16 is 52. That's right. And then you do plus 25 is root 77t. So that's how they got that. That's funny. So it depends on how far along that line you go, I guess. I've never done an arc length integral like this. Oh wait, S of t is just this. So is it just... This feels stupid, but do you just switch S of t and t and then resolve for S of t so you get t over root 77? I'm really confused on what that would mean. I don't think I get this question. But if your S of t is this, why isn't your inverse t over root 77, I guess? Isn't the dimension wrong? Yeah, I don't know why they're getting a vector. I feel like I'm missing something though. Because like, unless they really slept through their class, I assume they wouldn't be getting a a vector for no reason. Same formula, but as a constant rather than as a function. Okay, here's that. Was it R of t of s? Oh. Oh, maybe they did the inverse and then they did. They took the inverse and they plugged it into R of t. That's how they got that vector. But as the question is stated, the inverse of of s of t is just t over root 77, I guess. Inverse function theorem? What is that? Oh, uh, it's a good point, SPQ. I don't know why it brought me down there. Oh, like fundamental theorem of calculus? I think it's going to yield you the same thing as we would get here. Or like if I don't know. I think it might just be the way the question is phrased. Let's see if someone else is beating me to the punch here. Nope. I think it's this. Like the person did find the inverse right. I think they just weren't supposed to plug it into R of t. Oh my god. George watched 2 more shows than the number of music videos and 4 fewer movies than the number of music videos in all. In all, he watched 16 different videos. Calculate consumption per viewing videos. Oh my god. So you have 2 problems in one here, I guess. You have to figure out how many of each music videos, movies, and shows. Yeah, SPQ. I have a hard time figuring out what that really means. Like we can do it. I just don't know why you would want to. So I guess you want to set up an equation. If x is music videos, then x plus 2, x plus 2. Okay, so x plus 2 plus x minus 4 is equal to 16. Natural parameterization of a curve? Maybe, I'm not sure. I haven't heard of that, to be honest. George watched. Number of music videos is x, and they must add to 16. We can set up the equation x plus 2 plus x minus 4 is equal to 16 and solve for x. The x plus 2 is from the number of shows. The x minus 4 is from the number of music. No, movies. Just leave it at that. Hey, I called it. You just weren't supposed to to plug it in. That kind of sucks. The person did the problem right. They just did a little bit of extra work, so the website yelled at them. Um, maybe let's look for like one or two more, but I'm probably going to look to wrap things up pretty soon here. Let's see if we can find another one to do. Optimization problem? That could be fun. Lagrangian. Ooh, okay. Oh god, this looks a little... Oh no. Oh no. What is this? It could be fun. The length of sheet metal is to be made into a water trough by bending up two sides as shown in figure 14.8.3. Find x in phi so that the trapezoid-shaped cross-section has a maximum area when the width of the metal sheet is 2 meters. 2x plus y is 2. Oh my god. What is happening here? So, yeah, this person's... The trapezoid area formula. Is that it? All right, see you, Bob. Sleep well. Thanks for the question, even though it was Feynman. A plus B over 2H. That's not what they have, though. It's not... It's not x plus y. You take the two parallel sides. Okay, so we can maybe at least... Because I think they started off on the wrong foot, it seems like. So we can at least maybe get them a better formula for the trapezoid area. So the situation that we have, it's going to be a bit of a geometry problem, to be honest. Oh wait, the top side is 2. No, it's not. Never mind. Yes, it is. No, it's not. I don't know. No, it has to be less than 2 because we're bending it up. Y, X, X, B, B. We need to work out what this top parallel side is. So, and we also need to work out what the height is. How can we do that? Well, I guess we could look at instead these triangles down below here and know that this entire length is 2. And so each of these is 2 minus y over 2. And so by Pythagorean theorem, this, which is also the height, is hypotenuse squared minus other leg squared. We can make it a bit simpler too. Okay, that's not the prettiest thing, but it's something. And actually, is that entire thing too? If we, oh man, no, I think I made a mistake there already. Dude, I have to pee so bad. 2 minus y over 2 is x. Yeah, okay, yeah, you're right, SPQ. I made a mistake. The initial length of the sheet is 2, but I'm misusing that, like I'm not using that factor, right? Is it just trig? Like, the height, rather, sine of phi is equal to opposite, which is h, over x. So h equals x sine phi. That seems more reasonable. And then these bottom parts, which are also up there, cosine phi is equal to h over, we need some name, or not h. Just call it z, I guess, I don't know. Adjacent over hypotenuse, x. So z equals x cosine phi. So then the top side is y plus 2 x cosine phi. And the z is kind of irrelevant because we don't actually, we're going to do everything with x cosine phi, so. Okay, so that means your actual area is going to be y plus y plus 2x cosine phi. Three parentheses, right? Yeah. Over 2 times h x sine phi. I think I'm happy with that. I think it's enough to get the person to start, because I think saying that the area is 1/2 x plus y, I think is just wrong. It's convenient, but it's wrong. Misused is a word. And the other side is the upper edge of the trough. You can work out what the upper side of the trough is. trough is and what h is by looking at sine phi and cosine phi. Actually, let's get fancy. Phi phi pho fum. Problem for myself, but I think this will get you off to a better start. Okay. That could be a fun one to work out completely, but I don't remember Lagrange multipliers enough, and I'm getting a little bit tired, so I think I might call things there for the day, and I think Dan is live, so maybe we'll go over and raid him. Yeah, Dan's live. All right. I'm going to end the stream over on YouTube, so if you're here on YouTube, I appreciate you. Thank you very much for hanging out with me, but I'm going to end the stream here. I'll be streaming math again on Tuesday. No, sorry, Saturday, starting 4.5 hours ago, whatever that is in your time zone. And thank you all on YouTube. Oh, actually, YouTube, check out Zach's real analysis class in 1 hour and 15 minutes. And if you're interested, we're going to be hanging out in Danny Highway's chat in the meantime, if Nightbot ever wakes the hell up. Put some links in Twitch chat too. Why is, dude, does Nightbot... What the hell, Nightbot? There they go. Okay. All right. See you, YouTube.